Okay, so we are going to start with this third module 3.1 as an comparator. So we are going to study inverting comparator and non-inverting comparator. This is going to based on the input terminal where we are going to apply an input. Then we are going to see zero crossing detector and window detector as a comparator part. Then the second part of this module says we are going to study about the Smith trigger, where again, since we have two input terminal, we are going to see inverting Smith trigger and we are going to see non-inverting Smith trigger. That means we are going to study the circuit diagram working and we are going to observe what will be the output of this Smith trigger. Then 3.3 part says we are going to study about the waveform generators. So waveform generators means normally we are going to see the circuit which is going to generate the square wave or the triangular wave. So how the circuit we need to design to generate a square wave and a triangular wave generator, that we are going to see. Then we are going to see the precision rectifier. So first we'll understand what is this precision and then what is the rectifier, and then we are going to move further with half wave and full wave precision rectifier. And the last topic of this module says peak detector. So hardly this module is not going to take much 7 hours. We will complete before that, but in between I may have a class test for you people based on this module 2 and the topics which will be covered in module 3. So whenever in between any time I may have a test where again it will comprise of two parts. One is objective and one is subjective. Okay, so in subjective I may ask you a numerical or some simple questions which you may not have to write, so that will avoid for class work है ना, तो मुझे भी टेस्ट चेक करने में डिफिकल्टी होता है. So I will see to it that we'll have an objective types only out there or a very short answer where you can just write it in that form itself. No need to upload any document. That I will see to it. Okay, so this is what our module we are going to start with. Any doubts in this?
No,
And
miss.
okay, so till now the two modules which I have covered, I hope it is clear. And I have shared the module notes with you all in the Google Classroom, where whichever videos I have showed, I have shared the same videos links to you people. So you can open that links as per the topics whichever you want, and you can understand it very carefully. Okay, so we'll just start with the comparator. So first we will start with an inverting comparator. Let me start. क्या हो गया? एक मिनट हाँ. Okay. So let us start. So we are going to study the inverting comparator using op-amp. So let us see first what is the concept of comparator. So comparator is an electronic circuit which compares the two input signals that are applied to it and produces an output. And the output value of the comparator indicates which of the input is greater or lesser. So that means we need to see that two inputs which we are going to apply, uh, that indicates which input is greater or lesser. That is what the comparator is going to compare the two inputs. So comparator is nothing but an open loop op amp with two inputs and one output. So it compares the signal voltage applied to one input to op amp with known voltage applied to other output. Okay. So we are going to give some two input signal and we are going to see the output. So the output of comparator is either a positive saturation or the negative saturation, depending on which input is larger. So we have a known voltage that is DC type. So this output can either be a positive or the negative, depending on which input is larger. Okay. So comparators is having two types. Okay, just a minute. Okay. So comparator is depending on two types, that are inverting comparator and non-inverting comparator. So what is this inverting comparator that we are going to see right now? So an inverting comparator is a comparator when where the input signal is applied at the inverting terminal. So the name itself is indicating that the input is applied at the inverting terminal and reference voltage is applied at the non-inverting terminal of an op amp. So based on this only we are going to give the input. Okay. So non-inverting terminal will be not ground. We are going to give some reference voltage. So till now, what we have seen one of the terminal was connected to ground, right? When we are applying some input voltage. So here we are going to apply two inputs. So it is divided into two types. So one is inverting comparator with positive reference voltage and the other one is with negative reference voltage. So let us first see inverting comparator with positive reference voltage. So inverting comparator है. So inverting input is applied at the inverting terminal and reference voltage is applied at the non-inverting terminal. So what is the difference? So reference voltage is positive. So reference voltage should be positive. So this circuit diagram says here it in inverting terminal we have applied some input voltage V input and reference voltage has been applied to non-inverting terminal. So reference voltage has been connected from non-inverting terminal and ground. And so you can see the reference voltage, positive voltage is given to the non-inverting terminal. So this is what the waveform of an inverting comparator. So how this waveform has been run, that we are going to understand. Because if we are understanding this positive reference voltage, that will be understood by using this graph. So since it is inverting comparator with positive reference voltage, so that we are going to understand using this waveform. So even we have non-inverting comparator with the positive reference voltage. So this waveform may be confusing in that case. So how to draw this waveform, that we are going to study. So we'll just understand it basically with this waveform, that formula, that VD, that is differential voltage, that is equal to V1 minus V2. So that is nothing but voltage at the non-inverting terminal, differential voltage. So V2 is the voltage at inverting terminal. So you should understand it, where is this V1 and where is this V2. So V1 means a non-inverting terminal voltage and V2 means inverting voltage. So when you multiply with this lag voltage, so overall, so we will consider a case where input voltage, which we have seen, So we can write this as V reference minus V in. So this portion is our V reference, right? So the reference voltage ka marking we have showed it on this waveform. So reference voltage is but obviously above the zero voltage, and this dotted line which has been drawn down, where it intersects, from there we are going to draw the perpendicular line for a waveform. So this points, you can see where we have intersected this sine wave V reference line. So we have showed the waveform in terms of V reference and V in. So V reference is greater value, that is the higher value. V in is the smaller value. So high value minus smaller value will be, so will be a positive value. So we need to see that whether this differential voltage is positive or negative. So if this is positive, then our voltage will be positive saturation. So for this, you can find we will have the output voltage as positive. So this particular second waveform, that is V reference, where it is smaller V input. So here you can see this is what V in, which has been shown out here. And in that basis, we can see the second case where VD will be equal to, second case, that is VD will be equal to smaller number minus the higher number. That means V in minus V reference if we do. So if, but obviously from smaller number, if we separate the larger number, we will get some negative value. So that negative value has been showed here by negative saturation. So for this duration, you will find there will be minus V sat, where your V in is greater than V sat or V reference voltage. So this is where we have written V in is less than V reference for this duration, and for this duration, your V in is greater than V reference. Okay. And if we, sorry, and when V in is less than V reference, the voltage at non-inverting terminal is greater than the voltage at the inverting terminal, and this makes the differential voltage VID positive, and hence the output will be in positive saturation. So this is what we have studied using this graph. So when V in is greater than V reference, the voltage at inverting terminal is greater than the voltage at the non-inverting terminal, right? So this is what where we have seen negative saturation. So now we will see with the negative reference voltage. So here what happens is we here the reference voltage has been given as positive with negative, right? So now that will be turning up to be negative. That's why it is called as negative reference voltage. So in circuit diagram, only one change will be there, that your circuit will have a negative reference voltage. So now this reference voltage, this has been reversed out here. So now we can negative supply which we have seen. So now we need to understand the same concept using the waveform for the negative reference voltage. So how it is going to work, waveform which has been showed, let us understand this waveform. So now VD is equal to voltage at non-inverting terminal minus voltage at inverting terminal. So voltage at non-inverting terminal, you can see that is the reference voltage with negative sign. So we can write it as V reference minus V in. So first case, now here we are going to consider what will be a first case, that is, so since your reference voltage is negative, so we have drawn this reference voltage below this zero, right? So then we are going to see the intersection to this sine wave, and we are going to draw perpendicular lines. So we can see here during this intersection point, so To draw waveform, we need to see the first portion. V in is positive and V reference is negative. So VD, where the first case will be having a V reference, that is the smaller value minus the higher value. So this we have stated. So V in is then higher value out here, that is positive. So that will be minus smaller value minus V in smaller, right? So that whichever value which we can write, that is minus V, or दोनों भी negative है, so the output will be negative. So here we can see that output will be negative, that is minus V side. And in second case, VD is equal to, so this is where the second portion where V in that is negative, but it is more negative, and V reference which is minus V reference with small value, and minus times minus V in, so that will be plus V in this case. So this is an higher value. So we can see minus times minus V in, that is plus V, which is high value. So that will give you a positive saturation value. Plus high, that is, we can consider this high value is positive. That's why VD will be equal to positive V side. So how in waveform which we have seen, that is V in which is less than minus V reference, and here where V in is greater than minus V reference voltage, and the operation working can be stated out here. So that is, when V in is less than the V reference, the voltage at non-inverting terminal is greater than the voltage at the inverting terminal. And this makes the differential voltage VID positive, and hence the output will be in the positive saturation. And when V in is greater than V reference, the voltage at the inverting terminal is greater than the voltage at non-inverting terminal. So this makes the differential voltage negative, and hence the output will be in negative saturation. Right. So please note down these two graphs I will show in the circuit diagram for inverting comparator. So as we have studied what is inverting comparator and how to it is having two input voltages, that is V in and V reference. And based on this V in and V reference, we are going to have one single output which is going to have the saturation voltages. So using this waveform and circuit diagram, you need to explain this inverting comparator. And in that inverting comparator, we have seen two types. One is the positive reference voltage and negative reference voltage. So what happens if we give the positive reference voltage to the waveform of your input signal, and what happens to the negative voltage if we apply the negative reference voltage? So I request you people to draw this circuit for inverting comparator with positive reference voltage. Once you draw this, then we will directly move to the waveform and note down the operation of this inverting comparator with positive reference voltage. Hope you all have drawn this circuit. So note down this operation and the waveform. So I have written this video was showing you the VD voltage, VID equation for just for your understanding purpose, ki how it has been resulted into minus saturation and plus saturation. So main thing in your examination, what you need to write is this operation. Done. So the next topic is negative reference voltage. So your circuit diagram says only there will be one change, that is this reference voltage which was positive will be now changed to negative. So draw this waveform circuit diagram for negative reference voltage. Okay. Then draw the waveform with the operation. Draw this operation for this negative reference voltage. Done. So now we'll move further with non-inverting comparator. Okay. Okay. So as we have seen the definition of comparator, so it stated it compares a signal voltage applied to one input to op amp which knows the voltage applied to the other input. So this is what a comparator does. It is going to compare the two input signals where one input is the input signal and the other one is known, that is the reference voltage. And the output of comparator can be either a positive saturation or the negative saturation. That is going to depend on which input is larger. So based on that, it has been classified into two types, inverting and non-inverting comparator. So now we'll move further with the non-inverting comparator, as we have studied the inverting comparator right now. So in non-inverting comparator, as it is stated, non-inverting where the input signal will be applied to the non-inverting terminal and the reference voltage will be applied at the inverting terminal of an operational amplifier. So based on that, it is divided into two types depending on the reference voltage applied to it. So non-inverting comparator with positive reference voltage and a non-inverting comparator with the negative reference voltage. So we'll see one by one. So first we will proceed with non-inverting comparator with positive reference voltage. So it is a comparator in which the input is applied to non-inverting terminal and the reference voltage is applied to the inverting terminal. So the reference voltage applied is positive in this case. So as per the name, we have designed the circuit. So the circuit says we have applied the input voltage at the non-inverting terminal of an operational amplifier, whereas the reference voltage is applied to the inverting terminal, and the reference voltage is applied as positive terminal of V reference is connected to the inverting terminal. So this is how the name itself, it says non-inverting comparator with positive reference voltage. So you please draw this circuit diagram for the non-inverting comparator with positive reference voltage. Okay. So we'll start with the waveform for non-inverting comparator with positive reference voltage. Okay. So we'll see the operation or how this waveform has been resulted into a positive saturation or negative saturation. So here we'll just note down the formula stating the differential voltage VID is equal to the input at non-inverting terminal minus the voltage at inverting terminal. So the non-inverting terminal, as per this diagram which we have stated, we have applied the input at the non-inverting terminal and we have applied the reference voltage at the inverting terminal. So we can write this equation as V in minus V reference. Right. So if you see this waveform out here, this waveform input voltage, this is the waveform for your input voltage. So when we draw a line of the V reference, and at this point out here, you can see the input voltage is less than the V reference voltage. So what happens when V input is less than the V reference is, or you can say your V reference, that means V input is less than the reference voltage, so V input will be smaller and V reference is higher. So smaller value minus the higher value will result into some negative voltage, right? And therefore we get this output of VID for smaller V in as negative saturation, and therefore you will get the output will be minus saturation, that is minus V sat. So this is where in waveform you can see it is going to have a minus saturation voltage out here. So this is what is your minus saturation voltage. Okay. So where V in is less than the V reference waveform. So further we can draw this diagram. So even we can consider this case where your where you can see V in minus V reference, where V in is negative and minus V in and V reference is positive. So it is minus V reference. So we can consider that even if we apply some small value out here, two negative values will be added and therefore the output here will be in negative saturation. So definitely the output will be negative out here. So now let us consider this case where we can see, we can state that it is the second case where V in is greater than V reference. So definitely it is going to, as per this formula, that is V in minus V reference, that is higher value minus the smaller value, which will always be positive, and therefore the output will be V set. as it has been showed out here. So this is the working for the non-inverting comparator. So please note down this operation where we have written when Vin is less than the V reference, the VID is negative and therefore the output will be in negative saturation. And for second case, when Vin is greater than V reference, here this is the case where the output will be positive and hence the output is written as positive saturation. So please note down this point. Okay, done everyone? So now we'll move further with the second type, that is non-inverting comparator with positive reference voltage. Sorry, negative reference voltage. So as stated in non-inverting comparator with negative reference voltage, what will be the change? The change will be uh, here the reference voltage will be negative in at the non-inverting terminal. So as we know, the comparator in which the input is applied to the non-inverting terminal and the reference voltage is applied to the inverting terminal, and the reference voltage applied is negative. So the circuit diagram will look like, let me show the circuit diagram. So here this is the circuit diagram for negative reference voltage, where you can see the entire circuit is same, where input is applied to the non-inverting terminal, but only at the inverting terminal you will have negative reference voltage which is applied to this input. So this is what the circuit of non-inverting comparator with negative reference voltage. So moving further with the waveform, so please draw this circuit diagram. See, whenever questions are asked, see to it that your circuit diagram, your waveforms are more clear as compared to what you write. Instead of writing more, your diagram speaks more. So wherever in this LIC you are having circuit diagram and waveform, please focus more on this circuit diagram and waveform. Okay. So moving further with the waveform, so this is what the inverting comparator with negative reference voltage. So as you can see here, your reference voltage is negative. Your formula will remain same, that VID will be equal to V in minus V reference, right? So so okay. So please write down this operation. So you can see here your VID can be written as V in minus of minus V reference, because V reference is negative voltage. So therefore your equation will become as V in plus V reference. And the values out here at this different cases you can state for so V in when it is less than the V reference, that is what we need to understand. That when V in is less than the V reference, the voltage at non-inverting terminal is less than the voltage at the inverting terminal. So which will make your waveform to be minus V sat. And when V in is greater than the V reference, the voltage at non-inverting terminal is greater than the voltage at inverting terminal. So this makes the differential voltage to be negative. So this will make it as minus V plus V sat value, positive value. So this is how the waveform shows out here because of this formula, that is V in is equal to VID is equal to V in plus V reference. So you need to draw this waveform of input sine wave, and which is going to give you plus sat and minus V sat value. So that's all for this today's lecture, where we have covered up inverting comparator and non-inverting comparator. Okay. Hope you all have jotted down. Okay. So we'll take your attendance. Roll number one, Saurabh. Roll number two, Nitesh. Roll number three, Drumil. Am I audible dear? Drumil. Roll number three.
Yes, ma'am.
Yes. Roll number four.
Present, miss.
Roll number five.
Present, ma'am.
Roll number six, Abhishek. Roll number seven.
Present, miss.
Roll number eight.
Present, miss.
Roll number nine.
Present,
Wait.
miss.
Wait. Roll number 10.
Present, ma'am.
एक मिनट रुको. 11. Roll number 11. 12. Give me 2 minutes, beta. 12. 13. 14. Runali. 15. 15. Kritika. 16.
Present.
17.
Present, miss.
18. Sachin. 19. Nayan. 20.
Present, miss.
21.
Present, miss.
22. Onkar. 23. Vishal. 24. Deepak. 24.
Present, miss.
25. Nikita.
It's 24 present.
Yes, yes, 24 is present. 25. Nikita. 26. Sainath. Okay. So thank you everyone. You all can leave.